Have you ever seen something called tensegrity? It's an unusual kind of three-dimensional structure where tension is dominant. It was invented in the 1960s by the artist Kenneth Snelson, and the philosophy was elaborated by the futurist and inventor Buckminster Fuller. Tensegrity structures are made of only things that push and things that pull, connected at their ends. In a way, it's really simple. In a tensegrity, each individual part either pushes constantly or pulls constantly, and that gives structure a whole different character. To make a tensegrity rigid, it has to be pre-tensioned. And there's something magical about holding a tensegrity in your hands. I think our hands can feel some things that our eyes can't see. My name is Gerald DeYoung, and in this series, I want to take you along on my journey of tensegrity discovery. My background is math, so for me, the most beautiful thing is the simplest thing. That's why I fell in love with tensegrity a long time ago. And being a software builder, I couldn't help but write some code to recreate this simple structural beauty as a mathematical model. Software is amazing because when you can model something, it's really easy to do experiments and to do a lot of them. So eventually, I got to a point where I could figure out how to grow tensegrity structures. Sharing the results on the internet eventually brought me into contact with the inventor of tensegrity, Kenneth Snelson, and I went to visit him for a day in his studio in New York City. He was building real-world tensegrity, and I was building imaginary tensegrity. I couldn't really compare my work to that of the master, but it was inspiring to see his physical work up close. I always wondered what I could do in the real world, with real materials, but I never had the time or the space to pursue it. When the pandemic hit a few years ago and everything was on lockdown, I found a quiet studio space, got some tools, and set about getting my hands dirty with building. I started the PretensT project, inspired by the open source movement in software, and with the goal of getting the idea of tensegrity out to as many people as I could, just for the beauty of it. First, I had to figure out how to build these things. And it took a couple of years of tinkering before I was able to make the hard part easier and build using mostly off-the-shelf parts. The foundation of my approach to building would be different from anything that I'd seen before. I wanted to be able to construct the tension network first, while it was still slack, and then insert the compression afterwards. I needed to have physical compression struts with adjustable length, so I could insert them when they're shorter and lengthen them to tighten up the tensegrity later. The solution I found was to insert standard bolts and nuts into the ends of metal tubes. Then, by turning the nuts, the bolts are slowly forced outward and the struts get longer. For the tension network, I found an amazing kind of synthetic cord called Dyneema, which is used for kite surfing, and it's extremely non-stretchy. But as usual, the devil is in the details. And here, the devilish detail is how to connect the cables together and attach them to the bolts. Let's just say it took a lot of trial and error, and that's an understatement. But eventually I figured it out, and then suddenly a whole new design space opened up. Then I added features to the software that made it possible to build real-world structures in a step-by-step way, directly from the mathematical model. The prefab tension and screw-tight compression approach allowed me to build high-tension objects which are rigid and long-lasting, consisting of hundreds of different lengths of struts and cables. Later on, I'll take you for a tour of each of these individual objects, showing how it was generated and what makes it interesting. But first, I'd like to bring this a little closer to home. One thing that I realized as I gradually got very familiar with tensegrity is that the only real way to get your head around it is to have it in your hands. So part of my mission is to do just that. Now, with the handy tricks that I've developed, I'm able to put together an easy-to-assemble kit that I can send to you. All you have to do is put it together at home and tighten it up. Your hands will be able to learn for themselves, and you'll have a tough tensegrity that you can refer to for years to come. In the next episode, I'll show you the first tensegrity that I built, and I'll show you how the new techniques work in detail. I hope you can join me.